What's up, pre-calc?
Hey, all you cool cats and kittens,
Miss Willis and
Miss Fisher.
yes, you get us both in one. How awesome is that?
One cool pre-cal video.
Yes. Guys, brand new. We're gonna start with something easy. This is Intro to Matrices. So if we were in school, this would be Unit 8, Day 1. A matrix. So we're just going to start with the basics, the definition. So a matrix. Now the plural form is matrices. So it's spelt a little bit different. Is a rectangular array of numbers written within brackets. Don't get those confused with absolute value. It's not the absolute value. You name a matrix with a capital letter. Okay, so when we talk about, so if you look at the first example, they've named it, they have named it right there with a capital A. So that right there is the name of the matrix. The number of horizontal rows and the number of vertical columns determine the dimensions. So dimensions of a matrix is super important. And if you get it backwards, it's wrong. So we find the dimensions by writing it by row and then columns. And that's not a multiplication sign right there. And we use that's by row by columns. And when we're talking about rows and we're talking about columns, the way I think about it is I think about it like an auditorium. A row would be going this way. So that's my rows. And then columns, I think about a building. Buildings' columns are up and down. So that's the way I think about it. Okay, my eraser.
Me too, Miss Willis.
All right, so each number in a matrix is called an element. You can identify a matrix elements by its position within the matrix. In this case, though, we use lowercase letters with subscripts. So you can see the example right here. This is us naming the element. So it's using the same letter as the name, but now it's lowercase, and then it's telling us the element that they want. It goes, again, row by column. So they're not trying to trick us. So it's the same order. So let's name the dimensions first. So this right here is my rows. So I have 2 rows by, I have 3 columns, 2 by 3. They want here in element or matrix A, they want element 1, 3. So that's 1 right there is the row. So I'm going to go to the first row. So that's the top row right there. And then I'm going to go to the third column. So the 3, that is the column. So the third column is that 4. This right here. First row, third column. The second one, they want second row, first column. So that would be the 6. So I have 3 examples right here. Let's see if you guys can identify the dimensions and identify each matrix element they want. So I would pause the video and try those 3. Welcome back. You should have some answers. This one, you should have gotten 3 by 3. Isn't that nice? That's a 3 by 3. And they're wanting us to go to row 2, column 3. So row 2 is right here. Column 3 would be a -7. That's my answer. All right. And then for this next one, I have a bunch of rows. I have 4 of them. So 4 by just 1 column, 4 by 1. And they're wanting the second row, first column, so you should have got 2. And then the last one, we have 1 row this time, and we have 3 columns. So they're wanting the first row because there's only 1 row, and then but they want the third column, so that's -3 is that element. So that is
Miss
the
Willis, do those
Huh.
letters always have to match?
Good question, Miss Fisher. I'm like 99% sure yes. Otherwise, we wouldn't be able. So if that said like C13, I would have to go look at matrix C, not matrix D. So yes, They do need to match. Otherwise, you can't name that element. Good question.
Hey.
All right, I'm going to stop sharing my screen. There we go. Yes.
Yes. All right. A matrix whose elements all equal 0 has a really special name. You want to guess what it's called?
Oh, I don't know, man. Is it called 100?
No. It's called a 0 matrix.
That's fun.
Okay. So that would look like if it's a 2 by 2, all the elements are 0. So that's what it would look like. All right, in section 2, we're going to be talking about adding and subtracting. Now, friends, you can only add or subtract matrices if they have equal dimensions. And you're going to do that kind of like you would if you were combining like terms. You're going to add and subtract the corresponding elements. So if it's in the top left corner, you're going to add that to the other top left corner. If it's in the top right corner, you're going to add that to the top right corner, and so on and so forth. So for example, in A, this number and this number are going to be added together. This number and this number are going to be added together. This number and this number are going to be added together, and so on and so forth. And so all you need to do is go ahead and add all of those things together. Or if it's a subtraction problem, you're going to subtract them from each other. So you're going to go ahead and do that. So for the first one, you're going to do 1 plus 3 and get
4.
4. Negative 2 plus 9. 0 plus negative 3. For the bottom row, 3 plus negative 9. Negative 5 plus 6. 7 plus 12. Okay? And then you're going to do the same thing for all of those. So I want you to try those on your own. So pause and try those, and then come back and see how you did.
Man, fish, this seems too easy.
It
It's too
is
easy.
too easy. All right, let's check your answers. All right, negative 12 plus negative 3. 24 plus 1. Negative 3 plus 2. 5 plus negative 4. Negative 1 plus negative 1. 10 plus 5. So that's the second one. The third one, 6 minus negative 4. Y'all got to be careful with these
Ooh.
minuses. When you
Can I
subtract a
show
negative,
how can I show my work for that? Is there a way to like so I don't mess it up? I feel like there's a way to like
there's always a way. Thank you for asking, Miss Willis.
no problem.
I like to do it in my head because I don't like showing work sometimes. But if you do that, you have to be really, really careful. So if you want to show your work, you do the whole keep, change, change business.
Yeah.
So to keep, change, change, you want to keep the first matrix the same, change this to a plus, and then change the signs of everything in the second matrix.
Oh, okay, okay.
How's that sound?
That sounds good. That made it way easier for me.
Okay, great. So now your brain naturally likes to add. So now you have an addition problem. All right, so now you got 6 plus 4, 10. Negative 9 plus negative 3. 7 plus 0. Sorry, my handwriting's sloppy. Negative 2 plus negative 6. 1 plus negative 5. 8 plus negative 10. And the last one, again, is a subtraction problem. So we probably want to
Keep,
keep
change, change.
change. Oh, yeah, good, Miss Willis. Keep change and then change all of these. All right, so you are going to get negative 3 plus 3. 0. 5 plus -1. -1 plus -2. 10 plus 4.
Just because it looks like a minus there, isn't that supposed to be an equal sign in front of that matrix? It's not
It
really supposed
is. I don't
yeah.
know what happened to that other part of my equal sign. Now, no, when you start with a 2 by 3 plus a 2 by 3, what size is your answer matrix?
A 2 by 3.
Oh my gosh, yes. Good job,
Can
Miss
I
Dawn.
add like a 2 by 3 by a 3 by 2?
No, because
Hmm,
then you don't have matching elements, corresponding elements to add together. They have to be the same size, like
okay.
it says here in bold.
Oh man, I wasn't paying attention.
All right. In example 4, it says use the data in the table. All right. So our data has years, it has verbal scores for males, verbal scores for females, math scores for males, math scores for females for average SAT scores. Now it says mean SAT scores. That just means average. It doesn't mean that they're like not nice. All right. So part A says write two by 3 matrices to represent the average verbal and math scores. So we are writing 2 matrices, and they are telling us the dimensions they want are 2 by 3. So you need to read that very carefully. That means we want 2 rows, 3 columns. And the reason this is a little bit tricky is because right now when you look at these, it looks like they've got 2 columns and 3 rows. So they want this oriented
Oh.
the opposite way of what it appears on our paper. So 2 by 3 matrices. So that means we kind of have to flip this around. So I kind of like to write out to the side what everything's going to represent. So we're going to have 1 row for males then and 1 row for the females. Females. So for the male scores, we have 507, 507, and 509. So 507, 507, and 509. And then for the females, 503, 503, and 502. So there's the average verbal scores. And then same thing for math, we're going to keep the males in the top row. So 503, 530, and 531. Probably need some updated data. This is old data.
Yeah,
502,
the kids weren't even
494,
born.
and 496. All right. And then it says find the combined average SAT scores for each year in the table. So if we're finding the combined scores, what do we need to do with these 2 matrices?
Combine. Well, when I combine like terms, I usually add.
OMG, yes. We're going to add those 2 together. So finding the combined SAT scores, we're going to add these 2 together. And so we're going to do 507 plus 503. That's going to be 1010.
Is that a good SAT score? Mm.
Not so much anymore. I think kids are striving for higher scores. I know when I took the SAT, I didn't study. I think kids study now.
I didn't even take the SAT.
Oh, see, well, there we go. So I don't know. This one's 1005. We got a 10.
37.
What else we got here?
997.
997,
Yeah.
they said.
Yep.
And then
1040. 998.
Thank you, Miss Willis.
You're welcome. That's what I'm here for.
All right. So that's adding and subtracting, friends. Matrix equations. A matrix equation, by definition, is an equation in which the variable is a whole entire matrix.
What?
Exactly. You
That's
can have
wild.
a whole unknown matrix. All right, so we can use addition and subtraction properties to help us solve for a matrix equation. So if you look at example 5, it says solve for matrix X. So note, in this problem, our unknown is a capital letter. Now,
Ooh,
Miss Willis, what does it mean if we have a capital letter?
we're finding a whole dang matrix, not just an
Yeah,
element.
yeah, we're finding a whole matrix. So capital letters mean matrix. So in this problem, when we see an X, that means our unknown is a matrix. So when the problem says X minus the matrix 1, 1, 3, 2 equals the matrix 0, 1, 8, 9, I want to know what matrix X subtract 1, 1, 3, 2 is going to equal the matrix 0, 1, 8, 9. Now, some of you might be able to do that in your head and figure that out. Others of you are going to want a more structured way to do this problem. So
Yeah.
ask yourself, what is the opposite of subtraction? Addition, yes, addition. So what I'm going to do to get X by itself is I'm going to add both sides by this matrix right here. So I'm going to add the matrix 1, 1, 3, 2 to both sides. And what happens on the left is when you add 1, 1, 3, 2, is this whole thing becomes a zero matrix. That all
What?
becomes, yeah, it becomes 0. So all you have left is matrix X will equal whatever you get on the right once you combine those two matrices together. So you get 1, 2, 11, 11. So that's your answer.
Is there a way that I can check my answer?
Sure, Miss Willis. You can take the X that you got and you can substitute it in. Let me get some of this out of the way. You can take that X, the 1, 2, 11, 11, and you can put it right here.
Mm.
And you can see this 1, 2, 11, 11 subtract 1, 1, 3, 2 indeed equal 0, 1, 8, 9.
Nice. I think it does.
I hope so. Otherwise, we did our math wrong. All right, in part B, you would figure out what X equals by taking this matrix and subtracting it to the other side. Okay, so we are going to subtract 8, 0, negative 3, 4, and subtract 8, 0, negative 3, and 4. Okay, that becomes a 0 matrix. So you get X equals, we get negative 2, subtract, oh, do you want me to do keep, change, flip?
Keep, change.
Oh, yeah, that's what I meant, keep, change. Sorry, I don't usually do that. So keep, change all of these. All right, so negative 2 plus negative 8 is negative 10. 7 plus 3, 10. 3 plus negative 0.
Well, -0.
Sorry, I just was changing everything. Yeah. And then 1 plus a negative 4. There. So that's your X.
Beautiful.
Questions?
I think that's pretty straightforward. It's just as easy as adding and subtracting. It's just a different form.
Yeah. You're just solving for a matrix.
Yep.
Okay. So in section 4, solving for a variable element. So solving for a variable element, you are now seeing that the unknown is actually inside the matrix. So it's representing an element or part of an element. So
Oh,
these can be pretty straightforward or they can be complicated, just kind of depends on how it's set up. But what you need to remember is that if these are equal to each other, then that means if it's in the top left, it's got to equal what's in the top left. Note, in the top right, you have a 4. In the top right, you have a 4. So every element in the matrix is equal to the other matrix. Okay?
okay.
So what I highlighted, 2x minus 5 has to equal 25. So what you end up with is just a pretty straightforward equation. 2x minus 5 has to equal 25. So it's pretty straightforward. From there, you just solve that and you get that variable that's part of the element. So we already know that the top left element has to be 25. So you're going to solve that. You're going to add 5 to both sides, get 2x equals 30. So x has to equal 15. All right, on the bottom right, those two elements have to be equal as well. So you get that 3y plus 12 has to equal y plus 18. Okay, so you're going to solve that basic equation. So subtract y from both sides, you get 2y. Subtract 12 from both sides, that equals 6. So y equals 3. I don't know why these keep highlighting. Okay. All right. The second one here is a little bit more complicated because if you look at the top left, you get 6a plus 3b equals 15.
Ooh,
So
there's
what's
two
different?
letters.
Oh, there's 2 letters.
Two letters.
And then you get that this 2 equals 4a minus 6b. So
Mm.
what do you think we're going to have to do in this one?
Oh, I think it looks like a system of equations.
OMG, it is a system of equations. So for this one, you're going to have to solve either with substitution or elimination.
Elimination, elimination.
I love how you think, Miss Willis. That's what I would do too. So those are your equations. 6a minus 3b has to equal 15 because they're both in the top left. 4a minus 6b has to equal 2 because they're both in the bottom right. Now, to solve by elimination, I'm going to choose to multiply a positive 2.
Oh, because we want them to be opposite signs. You gotta be careful.
Yeah, you got to copy down the problem correctly. So 12a plus 6b equals 30. And 4a minus 6b equals 2. So we get 16a equals 32. And then when you divide, you get a equals 2. That's so
Yeah,
much better.
yeah.
Yes.
That's only one answer, man. What about B?
Oh, that's where you take that and you substitute it into one of your original equations.
This is
I'm
doing
going
too
to
much.
choose, this is doing too much. Oh, thank goodness there's only one of them. So I'm going to substitute this into the second equation because that's the one I didn't mess up on. So 4 times 2 for the A. So I'm substituting that into here. 4 times 2 minus 6 times B equals 2. So you get 8 minus 6B equals 2. Subtract 8 from both sides. You get negative 6B equals, guess what? Negative 6. So B
Woo-hoo.
equals,
Yes.
there's your answers.
It was easy.
Yay.
Kind of. It's doing a lot,
Kind
but
of. It was a lot, but
mm,
yeah.
All right, because if you don't have it out, what I need you guys to do is to get out your handy dandy calculator. And if you're one of those kids that don't have a calculator, you have an iPhone maybe, and you can download Graph in Calc 83, and it's a free app. But I don't know how that looks. But we posted something in our Google Classroom for you guys to download a calculator. So, matrix multiplication. Now, remind me, Fish, am I supposed to do one of these examples by hand, or am I doing them all in the calculator?
No,
Okay.
all on the calculator.
So you can multiply them by hand.
I just put this little thing at the top about doing it by hand so they know that they can find it on YouTube.
Okay.
If you really want to know how to do it by hand.
Yeah, matrix multiplication, guys, is not as easy as you think. You have to multiply the elements of each row of the first matrix by the elements of each column of the second matrix, and then you have to add them together. Almost sounds like dot product, in my opinion, but you're doing it like 5 times, depending on how many elements you have. You can watch the YouTube video. Oh, I didn't read the rest of that. There it is, if you're interested. Yeah. But I am only going to teach you guys how to do it in the calculator. But the thing you have to realize is you can only multiply matrices only when the column of the first matrix. So let me get my pen back up. So column of the first matrix is equal to the row of the second matrix. So you have to know your dimensions. So what that's saying is, like, if I multiplied a 2 by 3, which one of those is my column? It's 3. So the only thing I can multiply it by is if the row, so this is the first, if this is the first matrix, the second matrix has to start with a 3. It can be a 3 by 1 though, a 3 by 4, a 3 by 5. It could be anything. Those in the middle have to match when you're multiplying them. So even if I reverse, so let's say I did a 3 by 1. I can do it this way, but if I did it by a 3 by 1, let's say I did it the other way around, times a 2 by 3, if you were to type that in your calculator or do it by hand, you would see that it doesn't work because they don't match on the inside. So they have to match. So just because it works one way does not mean it will work the other way around. Isn't that something? All right. We have given you the instructions. I'm not going to read those all.
Miss Willis. Yep. Miss Willis. If I just want the kids to know, if we were showing you how to do it all by hand, this would make a lot more sense why that's the case. So that's why I said if you wanted to see it on YouTube, you can watch a video on YouTube about it to have that make more sense. Because they might be saying, why in the world? Why? Why does it have to be that way? Watch the YouTube video. Good point. If you really, because guys, I know we're not really in class, but some of this stuff, some of you guys are going to take much higher level maths, and you do want to know the why. You don't want to just repeat the process. Sorry. All right, here we go. We are multiplying A by B. So first thing I like to do is name them, the dimensions. So this A is a 2 by 2 times a 2 by 2. Are we good to go? Yes. Oops. So 2 by 2 by 2 by 2. So that one, actually, if I multiplied it, it wouldn't matter which way I did it. So I'm going to turn on my calculator over here. So I'm going to go, so you can see my cursor. We're going to hit second matrix. It says it in blue, so that's the button I'm going to hit. We're going to go all the way over to edit, and we're going to hit enter. So we have to know the dimensions in order to use the calculator anyways. So we got to type them in. Right now, it's always defaulted to a 1 by 1. So I'm going to make it a 2, enter, 2, enter. And then I'm going to type in my, now it looks just like it, but with zeros. So it's a 0 matrix right now. I'm going to make it matrix A. So 3, -4, and you have to hit enter each time, 6. Okay?
Now I've typed in A, so I'm going to type in B. So I'm going to go back to second matrix. I'm going to go right to edit, but don't erase A. I got to scroll down so that I can type in B. And I got a 2 by 2. And then I have -2, 0, 1, 5. Okay, once they type them in, though, you do need to go back. So we can't go back to second matrix. We need to get out of this screen. We need to go back to our home screen. So I'm going to hit second quit. So we're back to our blank home screen. And now I'm going to go to second matrix again. And now I'm going to select the matrix I filled out. So see how I can tell that I've typed in them? A and B are both 2 by 2s, and hopefully I typed them in right. So I'm going to hit enter for A, and you can hit times. You don't have to, because if two things are next to each other, that means multiplication. And I'm going to scroll down to B, and then I'm going to hit enter, and looky there. That's a beautiful answer. So my answer is -13, 15, 14, and 30. That was pretty easy, right? Right. All right.
Oh, we can't do B.
Oh,
I
cuz
messed it up. Sorry.
we're gonna cross this out.
Omit.
You can't do B by hand. I mean by in the calculator because there's letters in there. Anything with D we can't do. So you can't. Oh, you could do
Oh
five.
yeah, we can. We can do
You
it.
could
We
do
can do
G.
C.
All right. We're gonna skip over to C. Well, thankfully, I already have those typed into my calculator. So all I
What's
gotta
the
do.
3 mean, Miss Willis?
Oh my gosh. So that's like we call that a scalar, right?
Uh-huh.
So that is we're scaling that matrix. We're going to multiply it. We're going to make it 3 times bigger. So we're going to multiply that B, that matrix B by 3. But if we just type it into our handy dandy calculator, it will do it for us. But really what that means is I would take matrix B, keep trying to get into the highlighter and it doesn't work. Matrix B, so this guy, and I would multiply it all by 3 before I add. So that would be like -6, 0, 3, and 15, and then I would add all those numbers to A.
Oh, I get it.
Good question, Fish. But I can also just type this in. So 3, second matrix, I'm gonna go down to B, plus second matrix, A.
And I don't have to put a time sign next to the
I
B, the
I
3B.
can. So if we went over here and I put in a time, so you can. Oh, I think I did something to my calculator. Uh-oh. Yes, we can. I'm gonna clear it out 3 times, but it doesn't matter. Like you don't have to, but you can. Because remember what I said earlier, if they're next to each other, even in the calculator, it understands it as multiplication.
Oh, so we don't have to,
No.
but we can, but we don't
Yes,
have to. Okay.
exactly. 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 So the answer here, get my pin up, is 2, 3, -1, 21. That's my answer. All right. CNA kind of looks suspicious to me just because if I look at Matrix C is a 2 by 3. So they're saying do a 2 by 3 times a 2 by 2. Do my insides match here? No, no, no bueno. So they don't match. And I mean, if you wanted to, I guess I could type this in the calculator. It's taking me forever to type in this calculator because I have to hit it. Oh, I gotta go. So I'm gonna put it in C. I'm just gonna show you what would happen. I know it's not gonna work because my insides don't match, but I'm just gonna show you. So 2, I guess maybe it works if I use my keyboard. -1 and hit negative. All right, enter 3, enter 7, enter, 0, enter, and then 4, enter. So going back to my home screen. That's important, y'all. So it says a C times, and I don't have to put the time sign because they're right next to each other, but you can. Error, dimensions mismatch. That's dim mismatch, dimensions. You can't do it. So this one is does not exist or no solution.
Wait, what's DNE mean?
Does not exist. Does not exist. Yeah, I think that's right. No such answer, no solution. You could even put like a little, some people do that for no solution. Okay?
Okay.
Oh no. So, friends, the bottom row, I'm gonna let you guys do those while I plug in my laptop. And then I'm just gonna post up the answers. How does that sound, Fish?
Sounds great. Well, what does I mean? Why does it say I? How come it's not just an E?
What do you mean?
How come
Oh,
it says matrix A, B, C, D? How come that's I, not E?
because that's a special matrix. We only use I when it's an identity matrix. And how do I know something is an identity matrix? It has ones down the diagonal right here, and then it has zeros in the other diagonal this way. Oh, I thought I changed colors. But that's the identity matrix. Good question. Good question. Because when we multiply, that's going to become helpful in our next video, y'all. It is going to become super helpful. Good question. All right. Hopefully you did these in your calculator. This is what I got. For this one, I got -16, -6, -12, and 33. This one, when I did it, I got an error. Wait, no, I didn't. I'm lying. Sorry, friends. I got 37. I was making sure you were paying attention. 36, 34, 4, and 12. That's what I got. Or at least that's what I got last year. So hopefully it's right. And then for G, there's that scalar again. So that means I just need to multiply everything by 5 in D. So I would have gotten 10, then I would have gotten 5x, and I would have gotten -5y, and I would have gotten 20. So all that means is just multiply the whole thing by 5. And then this one, I don't have an answer for, so I'm going to have to use my calculator. So 2, I think I have both those typed in. So B, second matrix, C equals, there's my answer. -8, 4, -12, 74, -2, and 46. Now, if I was taking a test on this, I think what I would have done was go and fill in all of those matrices into their right letters. And then I would have answered these questions. But that's just my way of doing it.
I think that's a great idea, Miss Willis.
Thank you. I have good ideas sometimes. All right, friends. This is our last one. You're probably like, thank goodness. Example 7, matrix G shows the gallons of milk sold at a dairy over a 2-week period. Matrix D shows the dollar amount per gallon. So they've given us both of them. If matrix P is a product of G and D, oh man, I gotta type these all in. All right, I'm gonna clear my calculator because I like to clear it. So second plus 7.
I don't think you need to type those all in, Miss Willis.
Why? Doesn't it say I need to? Oh, okay, let me reread it. Matrix P is the product of G and D. But I don't have the product. Oh, which element represents the total advertising fees for week 1?
Oh, I don't know if we can do this one if we don't understand how to multiply by hand.
All right. Well, then there you go.
Omit.
If you ended up doing it and you watched a YouTube video and you really wanted to do it, you really should have got C. C was the answer. I'm going to stop sharing my screen. And now, friends, we're done. You have the quizzes that will be due by Monday. Friday.
Monday? No, we haven't decided yet.
Yeah, but it will be due and it will show up in Google Classroom. And it will be fun. I hope you enjoyed this video and it made your day better, all you cool cats and kids. You can go back to making
all you cool dogs and puppies.
Yeah, my dog he's asleep. If you guys didn't know, I'm making this video in my bed.
Oh my gosh, he's been there that whole time.
He's just been sleeping. He snoozes. Snooze. All right, friends.
Goodbye, pre-cal people.